All right, let's get started here. So my name is Evan. I'm the CTO of Demox Labs. We are the team behind the Aleo wallet and a lot of other infrastructure on Aleo. Yeah, let's get into it. So kind of a high-level plan is I want to help you deploy your first program. I think Zach did an amazing job of showing like how to write Leo code. So I'm gonna try to go faster over those parts. There's a lot of awesome resources, but I think there's a gap in terms of how do we get from a Leo program to a full dApp where users can interact with it. How do you deploy your program on chain? How do you build a UI around it that can interact with that program? So let's get started here. The first thing that I recommend doing is downloading the Aleo wallet. We support Chrome, Android, and iOS. Here is a QR code. Here is a link. Currently, we have over 250,000 users weekly active on this extension. How many of them are real? I don't know. It's early days in crypto. It's a testnet wallet, right? But this is a good place to get started. If you open up our wallet, it looks like this. The first thing I'd recommend doing is going to our faucet. We have some instructions here. You basically join our Discord, you verify your identity, and you'll get some tokens to play around on testnet. If you have any trouble getting tokens at all, also just talk to me after, and I'll send you some tokens. So yeah, getting testnet tokens should not be a problem. If you spend more than a few minutes trying to do it, just find me or someone else on my team, we'll get you some tokens. So one thing I wanted to do to just kind of show how easy it can be to deploy a program. One thing that we recently added that is a really cool feature is called delegated deployments. So Aleo is a privacy chain, but deployments and deploying programs does reveal your address. So if you want to have a very private wallet and not reveal any sort of on-chain activity from that wallet, I do recommend as a developer separating your deployment address from your other address. In our wallet, it's pretty easy. You can just create another account and then privately transfer yourself some funds. But let's find a program to deploy. And yeah, this is all going to be live demos. So stick with me here. I hope everything works. But we'll find out. All right, so first thing we want to do is get a program to deploy. So we can go on chain. This, by the way, is AleoScan. It's Haruka Ma, who's an awesome developer in the Aleo ecosystem, made this. We natively integrate with it. We're just going to copy and paste a program and go to our demo site. So if you go to this demo site, you have the Chrome extension installed. You should be able to connect automatically. If you're not connected, it'll pop open a little confirmation modal. Let's go ahead and just copy and paste that code. We'll make it ETH Denver v2. The fee here is in microcredits. So sort of like every sort of cryptocurrency, they use integers. And when you hear like 0.1 ETH, it's actually like, I think it's what, 10 to the 9 Gwei. So there is a smallest unit of every cryptocurrency. We did not make it easier on you here, so you do have to kind of count your decimals, but it will confirm it in the wallet. So when we pop it open, you'll see a confirmation modal that has the program, the fee in Aleo credits, and we can go ahead and confirm it. So what we should see in the background is This deployment, generally in a ZK framework, we're actually creating a circuit. And this circuit, if you're familiar with how Groth16 works, oh, nice, already done. So if you're familiar with how Groth16 works, you actually, to create a proving and verifying key for each function, you kind of have to execute it and sample from parameters. In the case of Aleo, these parameters are provided by a universal setup, so you don't have to do your own setup ceremony for every program, but it can be really slow. So in the case of deployments, we delegate this to a powerful server who will do this process trustlessly for you, and then you get back your program. At this point, we're just kind of waiting for consensus to confirm that it's on chain. Similar to other chains, you can generate the transaction, but maybe it takes 30 seconds or a minute, plus the time for the indexer to kind of acknowledge that it's there. But we literally just deployed a program. So yeah, it's been accepted. We'll see it here in the wallet. You can see I tried this out earlier, but that's it. Deploying a program is that easy. So that's kind of like the first step. So now we have a program on chain. Let's make this, so some other features about the Leo wallet, like why are wallets so hard in privacy preserving chains? The first reason is that unlike other wallets, which are pretty much just a wrapper around an API and then a key storage mechanism and signing mechanism, in our wallets, you're actually generating proofs, right? So if you think about ZK rollups, they have machines with tens or hundreds of gigabytes of RAM who are generating these proofs. We're doing it on a phone or on a laptop, right? So this is a much trickier problem to solve in the case of a wallet. The other problem is that state is encrypted. So unlike most ecosystems where it's transparent, the RPC or client nodes actually control what state is. You just give someone your address, they tell you what your balance is. The RPCs don't know what your balance is. So all of this sort of state management in a privacy chain happens within a wallet, which makes it a much sort of trickier experience to figure out. And if you go to a block explorer, for example, they're not going to be able to tell you what your balance is, what your history is, without you granting them the permission to try to decrypt things, or without the wallet telling them that you did something. I'm going to skip down here. So I think Zach did a great job with Leo. I will show you some kind of specific examples of like how we do some sort of flows that I think will be common for programs, but let's get into kind of deploying your first full dApp. So we have this repo here. It's open source. You can go ahead and clone it. And I want to show you how to deploy your own NFT collection, but you can actually use a lot of this code to deploy any sort of program really, really quickly. So if you clone this, you should get, I'm not going to clone it live. I don't trust the internet that much, but you just make sure you're using a stable version of Node. I recommend Node 18 or 20, and then you run yarn dev. Oh, and then the only step you should do that before this is rename, it'll have an env file, rename your program to be whatever you want, and put in your public key. So these are the only things you have to change, and then you should get a website that looks like this. So this website has two main parts. One part is the user-facing side, which you're seeing here. This is kind of a mint page, so users can go here and mint. But probably more interesting is the admin page. So the admin page, notice it kind of looks like our demo page, but it's meant specifically to manage a program. right? So if you have an NFT program, you want to do things like deploy the program, which we have here. And it's exactly the same process. You connect your wallet, and you can deploy the program. You can initialize your collection. So you can say how many items do you want, what the symbol is, what is the URL for the actual images. You can manage a whitelist. You can add the collection, either item by item, or you can do it in bulk. You can manage all of these settings, right? So you can turn off the whitelist if you don't want a whitelist. You can turn on or off mint. But we really wanted to show you like a very realistic way that if you're familiar with Solana World, this is kind of our candy machine type example. So you can create a full website that automatically integrates with the chain. And there are a lot of awesome examples in terms of how do I fetch data from the RPC, how do I fetch data from the wallet, how to request transactions. And sort of one last piece that I wanted to talk about a little bit, and we're going to dive into kind of the Leo code that backs a lot of these. I guess I'll show you the base first. So one really common pattern in Leo programs is that in Leo, you're going to have both a public and a private representation of assets. So you sort of have this dual state. The NFT, this record object, is sort of the private representation of an asset. Depending on your application, you can either choose a private, public, or both. But there are certain things that make it way easier to do if you have a public representation. For example, if you want to sell your NFT, right? You probably, if you want to publish it somewhere and say it's up for sale, well, it's probably public. Versus if you want to store it or prove ownership, it's maybe some sort of token gating content, you can use the private representation. So records in Aleo, this is sort of the private representation of an asset, and mappings are the public. Something that we should kind of talk about as a limitation of ZK chains is that in ZK, you can't do everything privately. You can only do single party actions privately. But there are lots of examples, including like a simple swap, where you want atomic multi-party actions. You want basically to have two people agree to do something, and you want it to be all or nothing, right? You don't want money to be stuck if some party goes offline. You want to have, and a good example of this is a mint. So if you have a mint that it reflects some sort of public state, for example, your NFTs that are part of the collection maybe should be public. This way, users can trust how many NFTs are in the collection. They can trust that multiple people don't own the same item. But at the same time, we want to leverage the properties of ZK to make it as private as possible. So there are common patterns in these types of programs where if you can't make the interaction fully private, what you can do is at least make it anonymous. So if something requires public state, for example, like a swap, you don't actually have to reveal the public key of the address doing the swap. You only have to reveal the asset and the amount of that asset they're looking to swap. So this, I think, is kind of a subtle but really important difference between anonymity and full privacy. So if you can't do something fully private, anything that requires multi-party atomic transactions, you can do it anonymously very, very easily. So in the case of this mint, what's essentially happening here is we're creating a record for someone to basically claim later. So you're minting to a random number that you control. You have proof that you own this random number. The only thing that's revealed publicly is a random number. And then when you go to claim the NFT you minted, you can then assign it to yourself privately, while the only thing revealed in public state is the NFT and this random number. The actual owner of this is kept entirely private. Yeah, and this is an example of transferring private. It's pretty simple. You just change the owner of the NFT. This is kind of an example of, I think, a lot of us coming from more Ethereum, EVM land. Probably the UTXO model is a little bit new. That is sort of a quirk with how Aleo works, is that private state is represented as encrypted UTXOs, and public state is the account model. So do be aware of it, that if you have some sort of transaction that requires a private state and you want it to be read-only, you do have to output a new UTXO, because UTXOs can only be spent once, even if it seems like it should be a read-only program. One other use case, and I think this relates to how we imagine that things like ZPass are going to work, and something that I think is a really cool model is, well, I guess let's frame the start of it. In a public chain, you basically just have to prove you own an address by signing a message in order for someone to be confident they know who you are and they know what assets you own. So let's say you want a Discord that is token gated, where you have to own a particular NFT or some zk ID to be able to enter this Discord. In Ethereum land, you can sign a message, and that proves you own an address, and then that Discord can look up your assets and say, I can let this person in or not. What if the NFT is private? Well, you can ask the wallet what assets they own, and then the wallet could lie to you. And how do you check, right? How do you actually know that someone in an encrypted sort of state actually owns that asset? The answer is another zero-knowledge proof, right? So you use zero-knowledge proofs between clients and applications to prove that you own specific assets. So in the code here, we have this example of authorize, which, if we look at it, all it does is prove that in order to call this, and in order for it to execute successfully, you just have to pass in one of the NFTs, and executing this transition will actually create a zero-knowledge proof. Something that we think is important is that for this authorize function, the finalize block fails 100% of the time, which means that no one can broadcast this transaction. So if you create a zero-knowledge proof using Aleo's ZKP infrastructure, no one can then take this transaction and then broadcast it on chain, because I could rename this authorize burn, and it would burn the NFT if someone could broadcast it. But by having this sort of failure in public state, we can guarantee that no one can broadcast it. And then you can basically have offline execution, and this is a really powerful model, because if we're talking about building Web 2 applications that integrate with these ZKPs, we do not want to have them rely on things like consensus or things that take a long period of time. We want the sign-in to be as fast as possible. So if you generate an execution off-chain and then it is verified off-chain, then this sort of process can happen really, really quickly. So I'm just going to keep throwing stuff at you guys as fast as I can. So if you want to see other Leo programs, probably one of the most complicated ones that we have. And if you're, NFTs are great, but I think unless you're talking about like zkIDs, NFTs in themselves, especially like the PFPs, are a little silly, right? But I hope you see how like this sort of infrastructure can lead to things like zk identity. If you are more interested in the DeFi side of things, this is probably the biggest program we have as part of our repository This is a liquid staking protocol built on Aleo. It enables things like fractional ownership of like a delegator. It enables things like permissionless rebalancing across an open set of validators. It handles things like fee collection, implementing tokens, multiple tokens. It's about a series of, I think it's at 9 programs that all work together. So if you really want to see what it looks like to make something really complicated that mirrors something in other ecosystems, I would recommend checking out this repository. But if you're looking to get started and just deploy your own NFT as quickly as possible, we basically did that. So let's see. You could just go ahead and deploy it. Go check out this tab that there's a lot of settings too. Like if you're a programmer, I definitely recommend checking out our advanced settings. Like, you know, I turn off pop-up mode because I like the full screen, right? But if you turn that off, you can have the pop-up like all the other wallets. There are other features like auto-closing this generating transaction page, especially for deployments. This is nice to turn off. If you have any errors deploying your program, you can see them. And also things like resyncing. So if you have any issues getting your history, or we're in a test net, so sometimes the test net resets, you can do that. And let's check. There we go. We deployed an NFT program. So if I was to deploy this website using something like Vercel, which it's already set up to do, you basically just have to go to Vercel, connect it to your repository. You have your own NFT collection on Aleo. That is it. Any questions? Yeah, this is recorded, so I always try to get out as much information as possible. If you need to watch it later, it will be available. But I really just wanted to give everyone sort of an overview of what's available. Yeah, what's up?
Wallet is syncing up.
Yeah, so syncing is something that is sort of, if you're familiar with like Zcash, because the state of the chain is encrypted, how do you know which assets belong to you? Right now, sort of the default way is you look at all of the assets and basically try to decrypt them. And if you can decrypt them, then it belongs to you. This is sort of a limitation in, and this if you download something like Y Wallet, which is a big wallet for Zcash, it's the same sort of issue. So the problem is that the chain state's encrypted. No one can tell you which assets belong to you except you by trying to decrypt them. There are schemes that we're doing to dramatically improve this, so it's not quite as painful. But to perfectly preserve privacy, this is sort of the default use case. Zach's actually working on a P2P messaging protocol to help syncing happen faster in real time for current transactions. There are things like tagging that we're looking to implement to kind of reduce what you need to check. But this is sort of like the core 2 problems in privacy in an encrypted chain that preserves privacy. The core 2 problems that I think we're going to be working on for a long time. Everyone talks about number 1, which is proof generation, making proof generation as fast as possible. Every cryptographer has a new proving scheme that makes proof generation faster, and it's still an active area of development. Something that not as many people talk about is state discovery. So if, like Aleo by private, it's really encrypted. So all the data is public, but it's all encrypted. So how do you figure out which pieces of data belong to you, right, among all of the chain state? And that's kind of what syncing is. So sort of the practical ways to improve it, number 1, just making it faster. Like we can really optimize Aleo's WASM. So using things like SIMD, which are now supported in WASM, we can make it go a lot faster. But there are a lot of other kind of theoretical schemes to improve it. None of those are really kind of, this is something that Aleo is the first kind of chain running into because it's the first programmable private chain, and literally the only other sorts of chains that have dealt with this are basically Zcash, who never really figured it out. Yeah.
Can we get it recorded, please?
I noticed that the finalize function was still in there, even though it was empty. Is the finalize function required?
Which one?
It was in the NFT contracts.
Like this?
Yeah.
So-
Is that always required?
It's not. So if you think about why do we have transitions and finalized statements, sort of the separation is that a transition is being calculated off-chain, right? This is something that you're creating this execution and then a proof of this execution, but you're doing that all off-chain. The finalized block is happening as part of, like, if you were, imagine where does Ethereum go? It goes inside of this finalized block. So this is the re-execution model. This is the public code that everyone can see how it's being integrated with. It's not empty in this case. It is, we're asserting 0 equals 1, which will fail 100% of the time. So if you have some sort of interaction, if you have some sort of transition that you want to ensure that no one will ever be able to successfully broadcast on chain because you want to use it for offline authorization, you can just assert that it fails. Yeah.
Yes, so I have another question on the exact same function. So will I be able to, instead of making it purposely fail in finalized group, I return it during the transitions function? So I return the exact same NFT records.
Yeah,
Will that
so
work?
so you can do that, but then but it's not the same. The details are very subtle, but they matter a lot. If you just return the NFT, effectively what you're going to be doing is you're going to be burning a UTXO and creating a new one. And if you think about using the same NFT, like if I have a zkID and I'm using it to log into multiple websites, how does a website know that, like if you could transfer it, how do they know you haven't transferred it, right, to another user? The way that they know is that if you actually look at the input, there's a nullifier, or they call it a serial number, that is input here. And then this dApp can monitor the chain for that serial number being spent. So this enables a dApp to, or any website that's using this as an authentication mechanism, to basically watch the chain, and as soon as they see that serial number pop up on chain, they can invalidate your session on the website, forcing you to log in again. But if they don't see that serial number on chain, then they know that you don't have to log in again, and you can log in with like a cookie or something like that. Cool. I think we're good. Thank you guys so much for joining us. Really appreciate your time.